My name is Yoon-Sung Kim, and I'm very excited to share my work with all of you today. The title of my talk is Debian Official Debug Kernel for All. So this presentation will address a little gap in Debian ecosystem, and we will explore why official standardized debug kernels are essential for maintainability and security and proactive security posture. So yeah. So comparison with Fedora and RHEL and OpenSUSE. Yeah, Fedora and RHEL offers official kernel debug. Yeah, kernel debug. Yeah. Yeah. With some sanitizer and bunch of the debug configuration, OpenSUSE maintains dedicated debug configuration for memory and log checking and other many things. But Debian currently only provides a debug symbol. Yeah, debug symbol. If someone wants to take a debug kernel, forcing developer to build custom kernel. So my patch introduces official Debian debug kernels to address this gap. So yeah, there is three aspects for I wanted to emphasize. We must be realistic. Some of debug config and sanitizer is very heavy. It can make the system too slow. Also, simply enable all the debug config read to false positive because our generic environment is different. So I propose we establish a lightweight debug reference first. This aligns with what Qualcomm use for their common kernels. Yeah, so there is some table from this reference. Yeah, here, Qualcomm document. So before going full heavy with sanitizer and other some log checking, we should at least agree on these essentials, like debug spin log for logic errors to catch corruption for the spin log, and slop debug for basic memory checks. This set serves as a common denominator that every distro debug kernel should have, balancing performance and debuggability. And yeah, I want to introducing the middleweight things, a step up from the lightweight checklist. This level of the debug configuration can be highly verbose and significantly slow down execution, requiring a cautious application in real-world environment. The Qualcomm document list in here on the slide as a reference for more debugging options. Yeah, I want to introduce pain point for the some user and some teams for the user's request. The core problem we must solve is the more info needed loop. When a user reports a critical bug, such as system freeze or hang randomly, the development for the Debian kernel team finds it hard to reproduce and send back a request for more information. The fundamental bottleneck is that building a debug kernel is too high barrier for most users. Consequently, the user gives up. Yeah. The bug ticket remains unresolved, and critical bugs remains in hidden and unresolved. Yeah, I want to a proposal for the Debian Delta and Debian specific patches handling. In comparison to upstream kernel, there is a Debian Delta. The numerous custom patches Debian maintains that differ from the upstream kernel. Upstream CI thoroughly validates the mainline kernel, but Debian's unique patches in this directory, Debian under patches under some series of patches directory for outside the verification scope. Yeah. So currently, we have to rely on manual verification, which has a fundamental limitation, as you know. This is another important reason why we must introduce an official debug kernel. Yeah. So I suggest the solution, official debug flavors. My proposal introduces official debug kernel for the ANLIST, AMD64, and ARM64 kernel flavors. The implementation defines these new flavors in the define.toml and add the config.debug configuration. Yeah. It would be an enhancement and check for the 3 aspects in here. Memory safety, strengthened using some memory sanitizer like KASAN and UBSAN, and deadlock detection enabled by the lockdep, and coverage-based debugging supported by the enabling KCOV. Yeah. But you should remember that this is the a heavyweight configuration for the Linux kernel. Yeah. So I wanted to show the main use cases of the debug kernel, especially KCOV, with my tools named BOK. Visual Kernel Coverage Tool is a visualization tool that overcomes the limitation of the existing text logs and the message. BOK uses KCOV to record the kernel execution path triggered by a specific application and visualizes the execution flow and as a heat map on the Linux kernel source code. This provides a debugging environment of start seeing, and with the introduction of the official debug kernel, all Debian users can immediately use tools like BOK. So, yeah, this is some demo presentation for the BOK, but the PDF files are stopped for this screen. So yeah, you can see that is a GIF image in this link. Yeah. So this demo presents some, when I make some make.dr with some new directory, we can see the whole bunch of some kernel paths with some execution of the user application, and then we can see some Linux kernel that have some executing in the Linux kernel. Yeah. So yeah, I want to mention some SUSE in this session. SUSE, the kernel bug hunter. Google SUSE team has expressed support for Debian. We can provide the debug kernel images and headers, enabling proactive QA through SUSE. SUSE validates Debian-specific patches against corner cases. Corner cases, against the corner cases we can manually test. It provides a high-quality report, including actionable reproducers like a CDLang-based or a C program, and root cause analysis. This allows us to join the security ecosystem alongside with the, something like upstream kernel and Android kernel. So, yeah, I prepared some mailing thread with some Dimitri, who the SUSE maintainer and Debian kernel team members. So, Debian kernel maintenance is done in the Debian kernel team members in free time. Yeah, and they lack the manpower to handle a flood of the general bug reports. So the Debian kernel team can only accept report if the SUSE can filter for the Debian specific issue. So they can afford to investigate bugs that already existed in upstream mainline kernel, and they are willing to receive private reports only if the CDBot can accurately distinguish and filter for bugs that are reproducible only on Debian kernel. Yeah, issues introduced by the Debian patches. So I think it is a good point that CDBot have already have some filter function for they support Android kernel, so we can drop down the upstream kernel and we can see some filtered Android specific bug in the CDBot dashboard. Yeah, so CDBot team technically said we can distinguish them, but not sure about setting up the reporting workflow, because CDBot is technically capable of detecting downstream distribution-specific bugs with reasonable precision, citing existing success with Android kernel trees. But he expressed uncertainty for the exclusively send private notification for the specific Debian bug. So filtering for Debian specific bug and private reporting, mandatory condition for the Debian kernel team. But the CDBot have unsure if the automated reporting system can be configured. So this is some issue in this now. So I wanted to say about if we take this chance, we can make the security response from the reactive approach to a proactive approach, like detect via fuzzing and fix silently, release secure kernel would be to a proactive approach. The proactive goal is to detect bug via fuzzing, fix silently, release secure kernel. It emphasizes that memory safety issues account for upper 70% of the vulnerability. Catching this issue at the bug stage prevents them from becoming exploit. So I wanted to suggest some roadmap and challenges. Key challenge is including multi-architecture, various page sizes supported by the especially ARM64, and as you know, some of architecture support a real-time kernel, so we can add more X in here in the entry, and there is some 3 types of the sanitizer that Linux kernel support this now. So there is so many combination. So this is also problem. Build time are very increased, about the 3 times for some sanitizer and compiler instrumented configuration. As you know, the kernels are, there's a lot of kernel for this combination. The storage, largest storage package size cause some storage issue for some community-based ecosystem. So I wanted to suggest some roadmap proceed in 3 pages. Page 1, pilot and assessment, release debug flavors in the experimental repository to assess infrastructure impact. And phase 2, CI automation, incorporate boot test with sanitizer into SARSA CI pipeline. And page 3, ecosystem expansion, extend coverage by integrating with CDBot and kernel CI. So by introducing the debug kernel, we can convert unreproducible bugs into actionable reports, reducing issue resolution cost. we can improve quality through the automatic verification of Debian specific patches. So my key message is that debug kernels are not a waste of the resources, but an investment in maintainability and security and call for discussion. So I want to talk about this. Let's discuss flavor.debug official in Debian. Yeah. So
Fedora's been doing this for a long time,
Yeah.
and I can give you some hopefully tips and insight. In fact, what we did for years, over a decade, was the rawhide kernel. When you had an rc.x release, was a regular production kernel.
Yeah.
But we've always built regular production kernels and debug kernels. What we did for over 10 years was we forced rawhide users, if you were updating daily, every Linux snapshot build. So basically Tuesday through Friday, those builds were debug kernels only. And we forced users to use them. And that was a great way to expose a lot of bugs. The real problem you'd run into with this is upstream starts overloading debug config options. So you can take the time and create a debug config that is fairly well balanced and not too much of a burden on the users and gives good information. And then suddenly 2 years later, it's not usable. You can't run a desktop on it because it's just too slow for certain things. So we've now gone away from that, and we don't force anybody to use debug, but we build debug kernels with every single kernel we build for production, for rawhide, for everything. And then we have some automated testing on all of that. Yes, it does increase the build time. It increases storage drastically, which not too much of a problem there. Now, Debian's probably also got the same problem we do in that, RHEL can do builds internally and push them out when a CV is released, right? But with Fedora, everything we have is open. So I can't commit a fix until a CV is public, and then I have to worry about build time after that. So when you start introducing too much build time, it gets, it hampers your CV reaction time, right? So that's also somewhat problematic. But you will have to constantly look at build options and say, is this still a usable debug kernel? And also race conditions end up in a weird state that sometimes those debug kernels make them go away because you've slowed down the kernel so much that the race is no longer there.
Yeah.
So I'm not saying it's not worthwhile. It's very worthwhile. We continue to do it. We continue to test on it. But it is also, it's not just a set it and done. It's kind of a constant, what are our debug options now? How are they performing? Are they useful? And are they worth the overhead that they're introducing?
Thank you. Thank you for great suggestion.
Yeah, I kind of second that. We had the same thing in production. We created a debug kernel, and years later, I figured out that the options that I'm setting are not even in the config file anymore, which I should have checked for. Yeah. My question is, have you considered, like, one of the things that we kind of like stumble upon when trying to introduce debug kernels is like some options are mutually exclusive, so you cannot have KASAN and KCSAN enabled simultaneously.
Yes.
So how would you think addressing this case?
My great references is some Fedora and RHEL debug kernel. So my works only focused on the KASAN, some mutual exclusive condition, and I follow up some other references for the cases. So I think when I forging the Linux kernel and research for some vulnerability, KASAN is the good de facto for the debug kernel, and the speed is almost much faster than other configuration. So I want to start with the KASAN and some major configuration based on the other distribution. Thank you.
What about also KFans, which is the lighter version of KASAN?
I think KFans is good for the debug configuration. So I need to consider those things.
We enable KFans in our stable
Yeah, that we also do it in prod. But you can even disable it in a command line. But
Exactly. So yeah, I mean, it's there in the stable kernel. So yeah, if you want to do KASAN versus kfence, so our debug kernels have KASAN, and then we have kfence in our stable kernels, and make everybody run it. The overhead is just not. There is overhead, but it's small.
Thank you.
Has he been waiting for?
Oh, yeah. So I know earlier in your slide you mentioned how performance was a big thing. You don't want it to be too slow for regular usage. I also see in your patches you're enabling KASAN, you're enabling proved locking, which is all of lock depth configuration, and you're enabling KCOP. From experience, because I run that configuration with a whole bunch of other debug configurations against syscaller on a local instance day to day. That is tens, if not hundreds of times slower than a kernel built without those. So that is absolutely not a configuration that people can deploy widely. I'll give it to microphone to you in a second. So I would recommend that there are two very different cases of like automated fuzzing in an automated system and something you can actually deploy. And I would not conflate the set of options that you use for those. There's like some common things you probably want in those, but I do not think you want all of those like in the configuration you give to end users. I think that's not going to be practical to get useful data out.
Locking in specific, it used to be that was the one option that we determined that I was not willing to turn off in our debug kernels because it gives too much good information. But over time, for years, like I said, we forced rawhide users to run these kernels, and proved locking wasn't that big of a problem. But it was probably 2 or 3 years ago that the overhead, people started adding more functionality to it. The overhead got too high, and it's no longer usable as a desktop configuration. And that's why it's still in the debug kernel because I wasn't willing to turn it off, but we don't force the debug kernel on users just because of proved locking.
A lot of these debug options, like the overhead they add is not additive, it's multiplicative. So like you go from each one of these having a minor overhead individually, but as soon as you enable them, you're 10, 100 times slower.
Other question?
One thing that was tossing around in my mind at one point is things like Sysbot a good way to work out if what we would call in the embedded business the evil vendor kernel? Can we use that to evaluate evil vendor kernels versus mainline?
Sorry?
So
Yeah.
with embedded boards, usually we get some vendor kernel with a lot of extra patches in it.
Yeah.
If we run Sysbot against the vendor kernel, how can we evaluate that output versus a mainline kernel that it may or may not have derived from?
So you asked me some how can the Sysbot support the vendor specific kernel?
Yes.
Yeah. So I can introduce to you that there is some guide for some seed color can enable the specific remote machine and some essential configuration for the some other some kernel. So there is some official document. So
So the tool, your tool that you we're going to demo that starts with a V. Is it VOC or?
Yeah, VOC. Yeah.
VOC. Okay. So that looks pretty cool. I think I've seen some video of it in action.
Yeah.
And it looks pretty like an amazing debugging tool. So that depends on. Does that depend on a debug kernel package existing for Debian? Does it rely on that to run?
Especially, I mentioned that Dmitry, the essential configuration for that application is the kernel config KCOP, kernel coverage. So the kernel coverage makes some user applications, some code paths.
So if you have a debug kernel with KCOV enabled, then you can use your tool.
Yeah.
Okay.
Right.
Have you thought about porting your tool? Is it Debian only, or are you looking at porting your tool to other?
This tool is not related with some specific distribution. So yeah, you can enable the KCOB, you can use it. Yeah.
So I have a question. I'm looking back my memory in my previous project as embedded developer, and if I add the 2, 3, or 5 debug configuration, and I saw the boot failure sometimes, and kernel image size was increased so very higher because it is more than 2 megabytes. So I think that could you consider provide some of the information that this debug configuration will increase this size of the kernel image? If you provide this kind of information, and Debian kernel team will not be afraid of your suggestion. That's my suggestion.
Thank you for the great suggestion. Yeah. So yeah, almost 59. Yeah. So yeah, I wrap up my session. Thank you for joining my session.